Let's perform a hypothesis test on a claim concerning a proportion. A delivery company makes the claim that most people are uncomfortable with drone deliveries. So before we even talk about what we learned from our study, let's just break that claim down into a null hypothesis and an alternative hypothesis. The null hypothesis always concerns equality. And when we say most people are uncomfortable, we're talking about a proportion. So the null hypothesis will be that the proportion is equal to 0.5, right? Because most people means greater than 50%. Therefore, the alternative hypothesis matches the original claim that the proportion is greater than 50%. So we do a study from 1,009 people, and we find that 545 of them responded with, yes, they are uncomfortable with drone deliveries. We perform a hypothesis test using a probability threshold of 5%. So let's figure out how to use all this information. Our sample size is 1,009. The sample that we obtained, or rather the proportion that we obtained from our sample, was 545 out of the 1,009, which gives us, let's not say equal to, but if we round, about 0.54. So it is greater than 50%. In fact, let's draw that. We have a normal distribution, and unlike when we were estimating parameters, we do not center the distribution at our sample value, we center it at the null hypothesis. So 0.5. And our sample value, 0.54, is somewhere to the right. Now the question is, how far to the right? We want to use a probability threshold of 5%. So because we're talking about proportions, we should look at the z-score distribution. And if I want to use a 5% probability threshold, and my alternative is that p is greater than 0.5, then I can throw all of that 5% probability threshold into the right-hand side of my tail, or rather the right tail of my distribution, which by symmetry means that I have to have 5% in the left tail, which tells me that I have to have 90% in the middle. So if I'm in this region, if I'm in the tail, then that means I'm sufficiently far away. My probability of occurring is less than 5%. I would be surprised and I can reject that center of 0.5. So let's figure out what these points are. What are the z-scores that give me 5% into my tails? So remember, your z-score table has areas to the left of positive z-scores. So if I think about that positive z-score right there, then it has 5 plus 90 up to it. So 95% of the areas to the left of that. Here's my z-score chart, and I need to find a probability of 95 or 0.95. And I believe that I'm stuck in between two values. Right, 0.95 is right in the middle there. So the z-score that I should take is right in the middle. We'll take 1.645. So this is 1.645, meaning that this is minus 1.645. So where's our point, 0.54? We need to find a z-score. Remember, your z-score equation is your point of interest, our sample proportion, minus the center of the curve, that 0.5 right there, divided by standard deviation. Now, what standard deviation should we use? Because we're talking about proportions, we will use the same standard deviation that we did when we were estimating proportions. And remember, the proportion that you use to build that standard deviation is the center of your curve, just like it was when we were estimating proportions. So let's fill in the gaps. Our sample proportion was 0.54. the center of our curve is 0.5, and our standard deviation will be built from that 0.5 because that's the center of our curve. 1 minus 0.5 is 0.5, and n is 1,009. All right. When you go through the algebra, you should get a z-score of about 2.55. So where is 2.55 on our z-score? It's somewhere to the right of 1.645. Right, maybe it's right there. So it is inside that 5% tail, meaning that it is sufficiently far away from 0. So we are sufficiently surprised. The conclusion would be to reject the null hypothesis. So if I reject the null hypothesis, then odds are that the alternative hypothesis is true. The proportion of people that are uncomfortable with drone deliveries is most likely greater than 0.5. We got a sufficiently surprising result. Therefore, we reject the null hypothesis.